So this is problem number 2. It states that graph y is equal to the square root of 9 minus x squared. And again, this is more of a it's a problem that obviously involves graphing functions. So again, we have our x-axis over here, we have our y-axis over here, right? And so looking at this, the first thing I would really looking at this, I know that if x was 3, right? If x was 3, y is really just 0. Similarly, if you have x being negative 3, your y value is 0. So this is 3 comma 0, right? And this is negative 3 comma 0. Now, looking at the y-intercept, again, that's the value of y when x is set to 0. Well, that would just be the principal root of 9, right? And not, again, it's not you evaluating something like this, x squared is equal to 25, because for a problem like this, you will be seeing that x is equal to plus or minus 5. However, this one is specifically saying that we're only looking at the principal root of 9, and so that's obviously 3, right? So our y-intercept is 0 comma 3. And even if you think about this, right, if for instance you may be confused and you may, if you're not sure, you may say that 0 comma negative 3 is also a possible y-intercept. Well, if that were the case, then this function here would not really be considered a function, because it would fail the vertical line test. Remember, in order for a function, in order for a specific equation here, right, when graphing that specific equation, in order for that to be a function, it must pass the vertical line test, which means that for a specific x value, there must only be a distinct specific y value. So we obviously can have that here, right? Because this is a function, and so when we graph this, we get something like that. Obviously, your x value cannot be greater than 3, and that's pretty common sense. If you take 3.001, your x squared is going to be greater than 9, and 9 minus that value will give you will be really the square root of a negative value, and obviously you cannot have the square root of a negative value, right? So when we're talking about our x-intercepts here, right, again, best way, again, just to know, is if it crosses the x-axis, those points are the x-intercept. So that's 3 comma 0 as well as negative 3 comma 0. Your y-intercept is when it crosses the y-axis. That is 0 comma 3. And then we're looking at our domain, right? So our domain, again, is the real numbers, right? Real numbers such that we know that x is greater than or equal to negative 3, and then it is less than or equal to positive 3. And again, that reason is the same thing. Anything you take that is less than negative 3 or greater than 3 will give you a negative value here, which obviously cannot be a part of our domain. And now comes the range. So the range, just by looking at the graph, you see that it's real numbers such that y is greater than or equal to 0, right? And it's less than or equal to 3. 3 is the highest point, right? It's the maximum point here, and 0 is obviously the lowest point here, and so it makes sense that all your y values as part of the range must lie in between 0 and 3. And obviously this symbol over here indicates that it's inclusive, right? You're including 0 and you're including 3 as well. So that's just another one. Again, main characteristics of a graph when you're graphing is to make sure that you look at the x-intercept, the y-intercept, the domain, as well as the range. So these are the x-intercepts, the y-intercepts, the domain, and the range here. So the third problem here that I want to go over is another problem that has to do with graphing. However, it's a little bit different and it's more complex. Something that, if you can really understand, gives you insight into limits as well. And so the third problem I have over here is y is equal to the absolute value of x divided by x. And we want to graph this, right? So we want to graph this. So let's, we have our x-axis, right? We have our y-axis here. And so let's take any value. For instance, if we take 1, right? Well, 1 divided by 1 is 1. 2 divided by 2 is also 1. So if you think about this, it's something like this, where this is 1. You have this and it's ongoing, right? However, if you have 0 and you plug that in, you have 0 divided by 0. Well, that's the indeterminate form, and obviously, because you're dividing by 0, that is undefined. So at 0 here, we have this whole, right? So it's something where it's approaching, but it's not defined at that particular point. So at 0, this function here is not defined. So we have something like that. Okay, something that's going like this. Then we look at -1, right? And when you're looking at -1, clearly the absolute value again refers to the distance from 0. So if we're talking about -1, the absolute value of -1, that is 1, right? So we have 1 divided by -1. Well, that's -1. And so we have a point here. Similarly, you take, I don't know, -3. That's 3 divided by -3. That's also -1. And so you realize that it looks something like that. Something like that. And then at 0, right, you still have a hole over here as well, because it's approaching that, right? You always want to understand that when we're talking about limits, your one-sided limits must be equal. However, here, as you're approaching 0 from the right-hand side, right, it's approaching +1. And when you're coming from the left-hand side, when you're coming from the left-hand side to 0, right, your value is approaching -1, and clearly the limit of this particular function, right, as x approaches 0, does not exist, right? And the reason is that the one-sided limits are not equal, because you have that you have those discontinuities here, right, as shown by those open circles. So that's your graph here. And again, really, when we're talking about our x-intercepts, you see that it's not crossing your x-axis, so none of those x-intercepts exist. Y-intercept, also, it's none. And then your domain, right, if I'm talking about the domain here, so it's really the set of all real numbers. As you can see, it's infinitely going in both directions. So it's a set of all real numbers, however, such that x does not include 0. So x does not include 0, right? But it's the set of all other real numbers. And for your range, so I'll just say your range is here. It's the set of all real numbers, right? Such that y is equal to -1 or 1. So it's a set of all real numbers such that y is equal to -1, comma 1, right? So it's either -1 or it's 1, right? And those are the only y values that we're talking about. So you could also just say that it's y is equal to -1 or 1 instead of saying all real numbers. It doesn't really matter. But it's important to understand that your domain here, it's all real numbers except 0, because when you do substitute 0 into the equation, clearly it is undefined. So thanks for watching.